So hi everyone, my name is Curran. Yeah, I'm working at Alpine Data Labs in San Francisco. I've been there for about 6 months, and before that I did my PhD at University of Massachusetts. And my main project I'm working on at Alpine is called Chiasm. So first I'll talk a little bit about Alpine. So Alpine is headquartered in San Francisco. We're about 50 people. It's a nice sort of startup environment. We've been going for some years now. And we have a bunch of enterprise customers. So we sell enterprise big data analytics. So, data science on big data. So these enterprises sort of find value in us when they have data science workloads that maybe people are doing with R or Python or something, but then they just don't scale to the data that they have. So Alpine provides data science flows, machine learning algorithms for big data on Hadoop and Spark. And so within an enterprise, there's all kinds of different users. There's data scientists, and then there are people who want to sort of use the insights from data scientists. So Alpine sort of gives a collaboration platform for all these people. So the data scientists can make their machine learnings or data science flows and then save them in a collaborative environment and then expose them to other people in the company. So yeah, it closes the gaps between different kinds of people in an organization. And so we work with technologies like Spark and Hadoop and also a lot of different SQL database vendors. And I would like to give a quick demo of Alpine, the product. So this is the Alpine product. This is what people get when they buy Alpine. It's a collaborative environment with users. You can log in as a user, and there are many different data sets. And Alpine can connect to a number of different kinds of data sources, different kinds of SQL databases, Greenplum databases, Oracle, SQL Server, Teradata, Vertica, Cloudera, Hadoop, Hortonworks, Hadoop, MapR, Hadoop, PhD, Pivotals, Hadoop. So yeah, it's like a connecting fabric between all these different data systems. And you can have these things called workspaces. And a workspace is like this collaborative room in a way where many people can collaborate. So this is a listing of all the workspaces in the organization. This is just a demo, but in an organization it would be like, concerning different teams and things like that. And we're building out a permissioning system too. So here's one example of this credit analysis workspace where you can see like there's some conversations going on. The data sets involved are just these particular ones that are selected for use in this sort of sandbox kind of environment. And then there are work files. And work files are sort of the core part of Alpine that does the really hard work of the machine learning on Hadoop. So there's one I wanted to show, a credit delinquency model. So this is what it looks like, the visual flow editor for Alpine. So this is an example of a machine learning application where some tables are joined together from different data sources, a demographics table and a credit table. And then maybe the user created a scatter plot matrix just to sort of see what that looks like in the beginning. And then normalize in some way and then do random sampling, training and validation sets. And then use naive Bayes, logistic regression, and decision tree, and then plot those three against each other on an ROC curve to see which one performs the best. And then, use decision tree to actually make the prediction and output the results for somebody else to use in some application. So this is not my workspace, so I can't edit it, but before I copied it into my own workspace that I own. And so here's the version that I can edit. And notice the icons are different. We just switched out the icons recently. So. But yeah, this is what the interactive system looks like. You can drag and drop these things, and if you double click, you get these configuration parameters on the side. And so if I click on, for example, the scatter plot matrix, I can click this thing here and see the actual scatter plot matrix that was generated from the data. Oh, that's not what I wanted to see. Hold on. Yeah, this one. So it does, yeah, scatter plot matrix. It's one of these many features. If you click on the ROC curve, you can see those results on the bottom. Oh, I should update. Anyway, I think you get the idea. The curse of giving a demo, right? But I want to show you the ROC curve. I'm going to wait. So if you click on this, I always have to look it up every time. What was that from the audience? Right. Receiver operating characteristic. I don't really know too much about it, but it's a way to compare performance against different classification or regression algorithms. Here it is. So we have naive Bayes versus logistic regression versus decision tree, and the best performing is like the one that goes up to the corner, basically. And so, yeah, this is basically the Alpine product. And people can collaboratively evolve these flows, and you can drag and drop operators. Like if I wanted to make a box plot of the data, I could like drag and drop the box plot operator and then like make a connection between this table and the box plot operator. And then I have to configure it. Let's say age by education. I don't even know. So you set some parameters, and then you can double-click it. Oops. You can say run, and then it will, when you click run, it actually executes all this stuff on a Hadoop backend using Spark. So it's sort of, and all these algorithms are parallelized, so they can handle huge amounts of data. And so we get the box plot. It's not the greatest. I just picked random fields, you know, but it makes a real box plot, trust me. So this is my sort of quick tour of Alpine. Yeah, that's true. That's a great question. That's exactly the kind of thing that you could put like on a comment on this. And like, why did you choose this? I don't know. This is just a demo that I randomly picked up. But based on the ROC curve, you're right that logistic regression has higher performance in this case. But that's the kind of thing where like you could come at this demo and see that somebody else made it, and you could ask that in the comment system. And that's like a lot of what Alpine is selling. It's this collaboration platform. So many people can collaborate over these models, and many people can use them in the business. So that's kind of what I wanted to start with. But my main topic is this Chiasm project that I'm working on. So Alpine, yeah, I joined Alpine about 6 months ago, and I started this project then. And it's a continuation of my PhD work. So during my PhD, I made this thing called model.js, an open source library for, I'm calling them reactive models. And it's using like concepts from functional reactive programming, which is kind of an old tradition. There's a lot of like literature on it, academic literature, but this is kind of like just a simple implementation of it, where you write programs from the perspective of like, you say, I need some certain things as input, and whenever any of these inputs change, run this function, which will compute some other property as output. And then other reactive functions can depend on that output property as their input. So here's a simple example where it's like a first name, last name field, and when you type, you know, either of the names, then this full name thing appears with the, you know, the first name plus the last name. And this can be chained as well. So you can have X, whenever X changes, Y gets defined, and whenever Y changes, Z gets defined. And it works really well for making data visualizations. So here is the reactive data flow for a bar chart in this sort of visual language of these reactive flows. And all these things on the left are things that the user might want to configure, like the data set and how big the margin is, and like little things that you can tweak, like the axis label offsets and things like that, or the axis labeled text, and also like how's it sorted, what's the padding between the bars. You know, anything you can imagine that you'd want to configure can be a property in this reactive model framework, and then this sort of graph of functions will respond to changes in those inputs and eventually yield, this function is the one that renders all the bars of the bar chart. And so this is, like, in a way superior to, like, the way that a lot of people do D3 components right now, because a lot of D3 components, like, whenever you change something about the input, it recomputes everything. You know, it sets all the values of all the fields that could possibly change. But what this does is it only executes the functions that need to be executed in response to something changing. So, like, for example, if I change the label on the x-axis, it's not going to do anything else but change that text. You know, whereas if you change the input data, then it'll re-render everything, because everything depends on the input data. And so here's one example. Oh, that's the image. This works really well for combining visualizations together with interactions. So here's an example. This is the iris data set, which is used a lot in machine learning examples. Each data point is a flower, and there are like different measurements about the flower, like sepal width, petal width. And so here's a scatter plot of sepal width versus sepal length, and I could brush in here, and then whatever falls into that brushed region is used as input to the bar chart. And there we go. And the bar chart is, so it's aggregating the flowers by their species, and then showing how many of those species fall into each, how many flowers from each species are there. So like there's, you know, 8 that are versicolor in this selection. So using this paradigm of this reactive programming, I can just say very simply, like, make a scatter plot, make a bar chart, and then whenever the brush changes on the scatter plot, update the bar chart. And so, well,
with D3 now you can't. So it may be implemented in this example, maybe not. But there's like a micro library to do it. Yeah.
That's awesome. That's something I've been meaning to do, because like,
it's like a few months. But yeah.
Ideally, there would be like a very generic interaction framework where you could do things like a lasso and have like arbitrary shapes and like sort of draw like a pencil. I would love to do that, but this is just a square, just a lowly square right now.
Rendering on client side?
Yeah, it's rendering and doing all the aggregation. Everything's on the client side.
Can you make it work like Alpine? Can you make it work on Hadoop?
Oh, can you make it work and talk to something on the server? Yeah.
Rendering on client side.
Yeah, I'll get more into that. But yes, definitely. So like, you could set it up so that when the brush changes, it will send off a query to the server, which might do some kind of a big Hadoop job or a Spark job and do some crazy aggregation over terabytes and petabytes, and then give you the result, and then you could see the result in the other chart. And so maybe during that wait time, there would be like a spinner icon or something. But yeah, I designed it to be like that, where you can sort of compose these things arbitrarily. Yeah, and have even multiple levels of linked views. I'll show you that in a second, too. Yeah, so this is one of the demos. Some other demos from, and this is during my PhD time, before I joined Alpine. Oh, the font is too big. So here's another demo. This is showing population of world countries. And you can zoom on the map. And as you zoom in, it filters the input that's used on the line chart. And also, so there's this line chart on the bottom that shows all the countries of the world, the population over time. And so you can see, like, there's 2 countries up here that are much bigger than all the other countries in the world. Can you guess what these 2 are? Yeah. And so if you hover over India, you can see that it highlights in orange. So this is one pattern of linked views that I would like to enable in a more general way, where you hover over something on one visualization, and then that highlights the same thing on the other visualization. It could feasibly be implemented with the line chart where you hover over the line, but I didn't do it like that. Instead, if you hover over the line chart, it filters the data that's used as input to the map. So like this is showing in 1955 the population of the world. And then as you move forward in time, you can see the world population increasing. And so also you can zoom in on the map, and that filters what's being shown in the line chart based on what you can see. And you can see that you could see this dramatic drop in the population of Rwanda in the 90s very clearly. And this is only really possible if you have these linked views, you know, and you can dynamically filter and zoom in and things like that. Yeah, so this is the Rwandan genocide. But notice how the population jumped right back up. I found that sort of weird. But anyway. Yeah, so this is model.js, what I worked on during my PhD. And another part of my PhD was designing a generic system that's based on plugins, where each plugin is an instance of one of these reactive models. And that's what the Chiasm project is. And so Alpine hired me to basically continue my PhD work and make it all open source and integrate it on top of their big data analytics platform. So what is Chiasm? It's kind of a weird name. So one guy said, like, oh, you made that thing called Chiasm? What a terrible name that is. What were you thinking? Okay, here's what I was thinking. So the word chiasm, it refers to this part of the human brain, the red one, that sort of connects the eyes to the rest of the brain. And somewhere in the middle, it crosses. The optic nerves cross and then feed into the rest of the brain. And so I'm like, oh, yeah, that's perfect, because it's kind of like a metaphor for the eyes being like data visualizations and like interactive visualizations in the web browser, sort of connecting to these data systems, which are more like the brain, you know, that do all the complex analysis and stuff. So Chiasm sort of fits in the middle. It's a way to integrate data systems with data visualization. And so in terms of the technologies that we're using, so Alpine is built on Hadoop and Spark. A lot of it is done in Scala and Akka, which is a Scala framework for distributed computing. And also we connect to SQL databases. And so
Hadoop is distributed computing on disk, and Spark is distributed computing in memory. Is that right?
something like that. Yeah, Spark is, yeah, Hadoop. Who knows what Hadoop is? Okay, great. So, I mean, it's new to me. I never worked with Hadoop before I joined, but from what I gather, it's a way to do distributed computing over like terabytes of data. And there's a file system that comes with Hadoop called HDFS. And when companies have data that really scales beyond like what one machine can handle, a lot of what they do is transition to Hadoop because it can handle these huge volumes of data and also implement parallel processing over these data sets. So Hadoop, it originally came out of Google's MapReduce work, where like the map phase first, like it does some computation on individual computers, like maybe 50 in parallel at the exact same time, and then the reduce phase combines the results from all the different computers together, sort of boils it down. And Spark is kind of a reinvention of the compute model of Hadoop that's like more general, based on graphs, rather than a MapReduce. So the MapReduce is actually like one special case of Spark. I mean, that's what I understand. I don't really know that much about it, but it's like some newfangled magic that lets people do like really fast computations on big data. So, but what I know about is the stuff on the top, the visualizations, scatter plots and bar charts and things. So this is the chiasm. I took that shape out of the Wikipedia article about the brain, you know. So that's the chiasm in the middle. And what I want to enable with the chiasm project is to have like a system that scales along these three sort of dimensions. One of them is visualization techniques. So when I say visualization technique, it's like this idea of how to visualize data, and like a chart type in a way. So there's like scatter plot, bar chart, line chart, and many others, tons of other ones, like Core Plus maps we saw, maps with markers on them, parallel coordinates plots, tons. So I want to make a generic enough system so that in the future people can come along and add more plugins over time to sort of round out the space of visualization techniques. So far, I only have bar chart, scatter plot, and line chart. And the system also should scale to many different data sets. So if someone wants to use these fancy visualizations with their own data, it should be very easy to do so. You know, the thing that maps the visualization to the data should be in the configuration, not in the code itself. That's sort of one of the premises of this project, because a lot of the D3 visualizations you see are like the logic that deals with the specific data set is all there together with the logic that deals with how to make the visual representation. And so it makes it hard to reuse D3 examples. Because like when you try to reuse a D3 example, you go find some example and you say, oh, this example has some stuff that's hard-coded to one specific data set. How do I use it? I'll just copy and paste the code and then change the part that's hard-coded to their data set to be hard-coded to my data set instead. You know, and that's what a lot of people do, and it's successful to some degree. But it's hard to, I feel like there's a lot of wasted effort. Like, you could spend the effort better to make reusable components so that anybody could just pick them up and configure them with their data set. And so that's where applications come in. What I mean by application is like a configuration of the system such that it connects with a certain data set and uses certain visualization techniques together. And that's what an application is. So the demos I showed in my head are like applications. So the way that it works, it's based on a configuration. And so the Chiasm system is really like a runtime environment that takes as input this configuration. It's a JSON data structure. JSON is JavaScript object notation. Configuration of the application. So it's configuration of which data to load and also how to map that to the visualization and also which visualizations to load. Yeah, that's what I mean by configuration. And so Chiasm takes that configuration as input. Based on what's in that configuration, it dynamically loads whatever plugins it needs, and it also dynamically loads whatever data it needs, and then like makes the thing happen on the screen. So here's So here's like a more concrete representation of this process. So there's the configuration. Think of it as like a text file that's like maybe 100 lines or so. It's a JSON data structure. And then the Chiasm runtime sort of loads that into memory. And then whenever that updates also, the changes get propagated to the components at runtime. And so I'm using the term plugin and components in a specific way within the project. So a component is an instance of a plugin. So let's say you had two bar charts in the same application. The bar chart itself would be a plugin, and then each individual bar chart would be a component. That's just the terms I'm using. So the plugins create components. Yeah, components are instances of plugins. And there's this sort of bidirectional data binding in a way where like if the configuration changes at runtime, like if the user changes the color of something, that will instantly propagate to the components. And also the components can have interaction built in, like the brushing. And so whenever the user interacts with the visualization, that change will propagate back to the configuration. So that the states that you arrive at in the visualization, like for example, zooming in on Rwanda and seeing that crazy dip in the timeline, that's not implemented in Chiasm, but if it were, that state would be saved in the configuration. And then you could persist that into a database or something and then load it up later, and then other people could see the same visualization that you saw after you zoomed in. So here's a concrete example of a configuration. So there are four components here. There's the bar chart component. So this the top level. So this is JSON, JavaScript object notation, right? Keys and values that are nested. So bar chart, this top level thing is the alias. It could be anything. It's just like basically an ID, an identifier for that component. the alias.
We call it a bar chart.
Yeah, I'm calling it bar chart, which happens to be the same name as the plugin, which could be confusing, but I don't know. The plugin is also called bar chart. So each alias in the configuration maps to a data structure that has a plugin string, which tells the system which plugin to load, and then a state property, which is a set of key value pairs, which is the configuration for that particular component. So in the bar chart example, the plugin is bar chart, and the state is, basically what's the X and Y columns in the data set, like the column name in the actual data table, and then what should they be labeled in the chart. And often those are different. You have ugly, database column names. You want to have, some more nice, pretty label for it, And then a title, bar chart. There's some text that displays on the top, bar chart. So this is what you see when this configuration gets loaded, the bar chart. But I want to talk about these other components. This is kind of a degenerate case of these other components, but I'll just tell you what they are. So there's a CSV loader that loads a CSV file. And so in the system, loading data is totally decoupled from visualizing the data. And so this could be swapped out with some other plugin that calls into some arbitrary backend that maybe does a SQL query or something. But this just loads a CSV file. So the plugin is CSV loader, and then the CSV path is simplebars.csv, some file. And then it says, what are the numeric columns that I should parse into numbers before feeding them into the visualization? So maybe, how many of you have written D3 code? Okay. So a lot of the time when you write code with D3, you have to deal with parsing the data table, and you have to write some custom code that says, parse this column into a number and parse this column into a date. And that's also sort of tied up with the visualization logic. So I was trying to untangle those. So here's where you specify how to parse the data table. It's separate from the visualization. And then there's the links plugin. So what the links plugin does is it takes any property of any component and sets it to be the value for a property of a different component. So the bar chart CSV loader and the bar chart components actually don't know anything about each other, but then there's this other component, links, that says, it basically declares whenever the CSV data gets loaded, pass that into the bar chart as the data for the bar chart. And so you could use, well, I'll show another example later, but that's the basic case, right? Loading data. But it's a generic thing. You could use it with brushing and interaction patterns. And then there's the layout plugin. And this is a degenerate case of the layout plugin. The layout plugin is responsible for nested boxes. So you could have multiple visualizations on the page, or 2 on the top and 1 on the bottom. But now it's just one thing in the bar chart. So that's the layout plugin. The layout plugin is what connects the outer DOM element to the actual DOM elements of the component. So I want to stop and look at the GitHub repository and show some more demos. So this is the GitHub repository for Chiasm. There's some examples. And yeah, this explains the structure of the configuration, aliases that map to these components, which are comprised of a plugin and then a state, which is a key value pair mapping. This is JSON, JavaScript object notation.
No. I imagine it's marked down.
Oh yeah, this is Markdown. So the README itself is a .md file. So if you see the actual text, it's Markdown. Yeah, it's a really nice way of writing HTML. It compiles to HTML for the presentation. Oh, for the actual, yeah, the arrow thing, this is just sort of a made-up language that I made up for describing the structure of a JSON document. I know there's something called JSON schema, but I just didn't take the time to learn about it. But what it means is
the custom domain.
Yeah.
You're parsing through and pulling out the
Well, this is just in the documentation. This it's just like a pseudo like structural thing. If you look at the actual configurations, it's pure actual JSON. Yeah. And one thing that may have been confusing is that this links here, it is real JSON, but in this links string, this is a little domain-specific language with an arrow, but it's inside of a string. So it's like, yeah, component alias dot the property, that's the output property, arrow, component alias, and then, so this, yeah, like this is the output that gets fed into this input. Yeah. Right, so I just want to sort of cover the README. So like, yeah, the layout plugin can do these nested boxes. And this is one example of a layout with multiple boxes. Like A and B could be on the top, split vertical, and then there could be a horizontal split with C and D. So this is kind of mirroring the tree layout structure from D3. When you do tree visualizations in D3, I was kind of inspired by that. But now you're using the tree structure to actually lay out the visualizations, you know? So that's the layout plugin. And then I have this dummy visualization plugin just to demonstrate how to make a plugin that's just like a box with some text and that X to make sure I got the width and the height right. Here's a demo of, this is like the first demo that I got working with Chiasm. And so it pulls all the plugins together. One of the plugins is actually this editor, the configuration editor, which is this like text editor. And if you click on a color, it pops up this color editor. It's really cool, right? This is a project by, yeah, all right. So you gotta, I can change the color over here and it updates over there. So this is the propagation I was talking about from the configuration into the runtime environment. And then also each of these dummy viz instances, oh, so you can change the text. Like, Houston, right? And also there's this, I can interact with this line to change its thickness. And this is the line width property. So if I change it over there, it changes in the runtime. And if I change it over here, it updates in the configuration. Unfortunately, it scrolls to the top every time, but it does change.
Yeah, so it's 126.
Yeah, right. It's a larger value. And if I can make it 0, right? Line width of 1. So yeah, that's the idea, like in its most basic form. And I could also do things like change the layout dynamically. Like if I wanted to, instead of split it horizontally, if I wanted to split it vertically, boom, I could do it like that. So the idea is like this, it's like a basic thing, right? The user has to edit text of JSON to do this, but you could imagine building out a nice user interface where you can sort of drag and drop everything and everything's dynamic, you know? And you could like resize things by clicking and dragging. Like that's where I want to go with this project. What was that? Oh yeah. So here's the layout plugin. Yeah, and the state is this tree data structure where the orientation is horizontal or vertical. So what I did is I just changed vertical to horizontal or the other way around. You know, change horizontal to vertical. What I did is I copied the text vertical, and then I, yeah, and then I pasted it to replace horizontal. But because like it's tricky to like actually edit the file because you get these weird inconsistent states. Like, I mean, actually, it's working. There we go. See, it works. Yeah, and so you can actually dynamically add and remove components too. Like if I wanted to make one that's called D, let's see, I hope I don't break it, comma. Yeah. Oh, it somehow got rid of it because it was named C. I don't know, but you get the idea. Like, it would work. So I could change it to D, and then like try to copy paste it, change it to C. There we go. So now I have D and C, and now I can add D there.
There might be a leading photo.
Well, I don't know. Just believe me, it should work. Yeah, they're named. So yeah, they have aliases, A, B, C, D. The text? See, I think it got into a broken state. Hold on. Refresh. But yeah, each of these have aliases now, but they can only be configured within the limits of their plugin. Yeah.
If you open the console, do you get some debug info?
Oh yeah, I would probably be getting errors. Yeah. And you were asking about the text inside? So that's a state property here. So I can change C to CD just right here. Text, the text property. So let me show some visualization examples. Here's one that's a bar chart and a line chart. And they're loading different CSV files. So there's a CSV loader plugin for each, and then there's the line chart and the bar chart over here. And you can do things like change the margin, configure the margin like this, and change the colors. Here is the Chiasm kitchen sink, which is kind of the state of the project, all the stuff that's implemented so far. This is kind of scrolling through a bunch of configurations. Yeah, 2 visualizations, you can resize them. The scatterplot plugin is something I worked a lot on, so that it can have these different levels of configuration where when you think of a scatterplot, you think XY, right? Just plot points as XY. But when you actually make a scatterplot, you realize that like, oh, the dots need to have a default size, and a default color. Yeah. And so here you can set the default size. There's a default size property in the scatterplot plugin. And there's also default color. You can change the default color and the default size. But you could also have them be data-driven. So here's, if you set the color column property of the scatterplot, here, color column, then you can set these colors, color range. So actually, the color for each specific data point is configurable here. So see, this is the iris data set again, and each color is a different species. So you can change that in the configuration as well. And also you can make size encode data as well. Yeah? No, I made my own model.js library, but the implementation. So all these plugins are instances of this library, model.js. And if you look at the source code of model.js, it's actually really small. It's like 100 lines, or, well, 200, less than 200 lines with comments. And that's the extent of the functionally reactive programming. So sometimes I hesitate to say it's really functional reactive programming because it's like sort of my take on it. And it doesn't involve like streams and signals and all that crazy stuff that you see in like when you dive into the literature. But it's just basic simple rules of like execute the function when any of the inputs change and when all the inputs are defined. That's the 2 basic rules that the library is implemented. Yeah. And I came up to a tricky situation with this scatter plot because like think about color column. There could be a color column, like a column in the data set that maps to color, or there could not be. So for the color column property, I ended up introducing this concept of like none, model.none, as like an optional parameter that may or may not be configured. But I ran into this problem of like all the properties need to be defined if you're going to have consistency between the runtime environment and the configuration. Yeah, it got a little complicated because everything should be reversible too. But a lot of details. I want to show this demo also of multiple visualizations. This is showing temperature of a few different cities over time. Yeah, so the line chart shows the temperatures varying over time, and it's the same interaction where if you hover, it filters the data used as input to the bar chart. So you can see that, like, at 9 a.m., Geneva was the hottest, and then, you know, the sorting order changes depending on where you're hovering. So this is actually using Chiasm, and I've implemented this little gear icon that will show and hide the configuration. So if you wanted to do something like, you know, change the size, change the color of San Francisco, you could do that right here, and it updates in both visualizations.
It's also about how you link the chart, how you map the change.
Yeah.
Mouse over that.
Yeah, definitely. So remember the links plugin from earlier? Let me make this editor a little bit bigger. Yeah, so here's this links plugin. This is a more complex instantiation of the links plugin. So it's loading the data from this Sense Your City API. It's actually calling into a live API. So this is like current temperature right now. It's not a data set. It's not a CSV file. It's calling into an actual API, live updating temperature. And so that was encapsulated as a Chiasm plugin. And so when the data loads, feed it into the line chart and also feed it into the Crossfilter. So there's this great open source project called Crossfilter that does client-side aggregation that's like really optimized and fast. So here's, yeah, it's this open source project from Square. And I'm leveraging this inside of Chiasm for doing like the brushing interactions. So like this is what this library gives you, like really fast interactive aggregation. So this is like 1 million data points or something. And each chart is showing like a histogram kind of. It's like an aggregated view into the data set. And so you can do these multi-dimensional filters, and you see how fast it updates. It's like insanely fast. So yeah, I sort of encapsulated Crossfilter as a plugin in Chiasm. It's not perfect, but it's a start. So I have an instance of Crossfilter here that says the dimensions to aggregate by are city and timestamp. So the Crossfilter is actually doing the filtering by one particular point in time and feeding that output into the bar chart. So let's look.
The x-axis on both, right?
Yeah, the x-axis is temperature on both. So, yeah, sorry. Y, right, vertical, Y. Temperature is the same, it's Y, yeah. But yeah, let's look in detail at these bindings, because it's like, so there's a field called linechart.selectedX, and whenever I hover, that property changes, right? So here's the line, linechart.selectedX. Whenever that changes, it feeds into senseyourcitydata.selectedTimeApproximate. Right. I ran into this weird issue where like you're selecting an actual point in time, but what you really want to do is filter by like a minute interval or something, because that's how often the data is collected. So I had to deal with that. Sense Your City data, yeah. So that's the selected time approximate. That's used as input, and then the output from that is the actual selected time, which matches up with the data, like a minute or something. Yeah, question? Well, actually, let me just finish this thought. So once we get the selected time, like a minute interval, because these are, I think it's 5-minute intervals. So the selected time approximate gets transformed into the selected time, which is one of these 5-minute intervals, which gets fed into the Crossfilter timestamp filter. And so the timestamp is declared as one of the dimensions of the Crossfilter instance. And so therefore, whenever that changes, this plugin, this component will sort of automatically recompute the filter based on that value. And so then crossfilter.city top is the top cities sorted, it's us sorting. The output of the crossfilter is the input to the bar chart data. And that's how the linkage happens. But it's all in the configuration. It's not in the code at all. That's really what I was trying to accomplish. And it's not the cleanest. I mean, but you never know until you try to do it. You run into these weird things of like having to come, round to the nearest 5-minute interval and things like that. But I basically got it working. Yeah. But there were 2 questions? Did I answer them?
Oh, no, I was just looking at it. So all this linking and parking, all this blah blah, arrow blah blah stuff, that's all in the link.
Oh yeah. So if you wanted to see,
I looked at it.
if you wanted to see the source code, yeah. So there's the Chiasm main runtime, and there's a plugins directory, and then there's the links plugin.
So it's mostly just the fact that you have events that are triggering when something, you're listening for changes whenever the source changes, and then you run the functions based on whatever is changed. So
right.
You found this to be sufficient, and like if you look at other functional reactive libraries before choosing to implement your
Yeah, so, great question. So did I look at other functional reactive libraries before implementing this? So what happened was I was making stuff with Backbone, and then I found myself implementing the same pattern over and over again for visualizations, which is call the function when any of these properties change, but only call the function when all of the properties are defined. So just to make it easier to build visualizations, I encapsulated that pattern, and then I realized, well, that's really the only thing I'm using Backbone for, so why not just make my own smaller library that just does just the minimum that I need. And then after I made this, I realized that it's called functional reactive programming, and then I started learning about these other libraries like Bacon and RxJS, but I never really dove into them. Like, I never really got any traction with them. So, to be honest, I haven't looked at them too deeply. Like, I haven't tried to implement visualizations with those libraries. But when I start working with them, I start feeling like, oh, this is a huge library. It just feels like overkill in a way for what I'm trying to do. But like, yeah, I still, whenever Bacon and RxJS come up, I feel like I should know more about them. So like, but
when you started out, you had been building visualizations that you pull out of that for them. So it wasn't that you set out to make the library.
Right. Actually, I came across this pattern over and over again when I was working on this one particular project. I was working at a cybersecurity company. Where is it? Here. Called Rapid7 in Cambridge, in Massachusetts. I did a summer internship there for 3 months. And this is sort of a write-up of what I did. So I made this, I actually used Leaflet and Marker Cluster for this. And I figured out how to customize the cluster representations to be D3 visualizations. So this is using Leaflet Marker Cluster, and each marker cluster is being visualized as a pie chart on the map. And when you zoom in, in Marker Cluster, well, if you don't know, in Marker Cluster, when you zoom in to another level, it sort of does this cool animation where it breaks the cluster into its like constituent smaller clusters. And so the effect of that with this is like when you zoom in on the map, the pie chart literally explodes into like smaller pie charts. And then when you zoom into those, they explode even more. But this is the project I was working on when I came up against this pattern. Because there was this linked time view. So this is showing user logins to a corporate network over time and space. And the green fraction is the fraction of failed login, like they entered the wrong password. And so there are interactions where So there's a bar chart that shows the different kinds of authentications, and then there's over time, how frequently are they logging in. And then there's interactions, like when you click on one bar, it filters the input to the other visualizations based on that bar that you click. And also there's brushing on the line, on the time view, so that filters the input to the other two visualizations just to be from that particular time. And it's all being done on the client. And so, like, at the time, this was like the most complex thing that I had tried to build, and like the code for it is not clean. You know, it's like just trying to hack it together to make it work. And then the patterns that I saw repeating, I tried to encapsulate in model.js. So I'm calling it functional reactive programming, but maybe it's not. You know, there's functions in those two other libraries, Bacon and RxJS. These are like the two JavaScript real functional reactive programming libraries. In both of those libraries, there's a function called win, and that has the exact same behavior as the win function in model.js, which is it takes, in the functional reactive world, it's like streams, I think, streams of changing values. So like whenever any of the inputs change, it executes that function. So that's win in functional reactive programming. So I'm just using that one thing from functional reactive programming. Yeah. So this is fetching live temperature data for 1 day at a time, and it's going back in time. So each time that chart updates, it's fetching 1 day's worth more of data. But in model.js, I did not get to the point of handling like diffs in the data. Like if you just wanted to add a few rows to the data set, in the way I've set it up, that would actually cause it would cause all the data to be re-rendered. But then it falls back on the intelligence of D3 of reusing DOM elements. So I don't know if you know about, but D3, like there's this whole enter, update, exit paradigm. So if you have like 5 records, you pass it through this cycle, it will create 5 DOM elements. And then if that data changes, but it's still at 5, it will not create or delete any DOM elements. It'll just change their properties. You know? And if you pass another data set through that's 10 elements, it will reuse the 5 that were there before, but then create 5 more. And also if you remove data elements. So like in the model.js world, it just deals with the whole data table as like a single value and propagates that whole data table through the system. But because the visualizations are implemented with D3, it's not creating or deleting DOM elements when it doesn't have to. Yeah. This is pulling live data from an API. There's an API called the Sense Your City data set. Data Canvas Sense Your City. It's some initiative from the Gray Area Foundation or something. But it's basically a REST API that you can call into and specify, I want temperature data for this interval of time. And they rate limit it to like 1,000 rows or something. So I'm like, well, how can I get all the data out? I'll just make a call and again and again and again, like for all the different days that I want. And so like this point here, it's actually today, or should be. And then it's just going back in time. So it's calling against an API. There's no simulation. And this is also using Crossfilter. If I select a region here, that it's sort of focus plus context, which is a common pattern in data visualization where you have an overview and then you can sort of zoom in, and that's the focus. The overview is the context. Yeah, focus plus context. So this is, you can like navigate through here, and then if you brush in this chart, it shows a connected scatter plot of temperature versus humidity for these different cities, only for the part that you're brushing over. And so if you look at a lot of data, and the performance is not that good. This is one of those examples where like I tried to push it to the limit, you know, and it's like the performance broke down. So, but yeah, you see if you select a lot of data, you see that each city sort of has its own cloud location in this space of temperature versus humidity. So probably based on historical data of temperature and humidity, you could predict which city it is. It's a crazy thought. And this is also Chiasm. It's just this configuration. And the links plugin for this one is like, well, it's not too bad. It's like maybe 15 links. But you have, like, there's 2 instances of Crossfilter because there's 2 levels of brushing here. So, yeah, like, this is interacting with one instance of Crossfilter, and this is interacting with a different instance of Crossfilter. But, yeah, it's Chiasm. It's all configuration driven. And you can do things like change the colors again, you know, for just one line.
The behavior where the stress at the top are hidden until you brush, is that something you can configure as well? Is that something custom for this one?
Well, to be honest, this particular one has a lot of custom. I did have to add a few custom things to get this to work. So like, but yeah, when you do load it for the first time, like the link for the brush hasn't triggered yet, so like the data is just not defined. But maybe there could be some workaround. I haven't quite figured it out. But like, yeah, But yeah, I mean, it could be implemented differently, where by default everything is selected, and so then when the data updates, this chart should update. Yeah. Yeah, there's room for improvement, definitely. Yeah, it would be great to be able to configure that default behavior of like if.
I'd love to configure it, but I do really like how it gets jumped.
Right, it's like a suspense. Like, what is this?
Where is it?
Yeah. And so, yeah, the current state of the project is like we're integrating it in Alpine, and from the sort of technical perspective, all the plugins are in separate files, JavaScript files, but at Alpine, we're using Ruby on Rails as the web application part that deals with the user login and things. And so I needed to make this stuff work with the Rails asset pipeline, which was a real headache. Getting all these things into one file, like one JavaScript file, and then loading that file into the Rails asset pipeline. It was sort of a headache, but I ended up making this Chiasm bundle thing that just sort of references all the plugins and pulls them all together into one module, and then that gets exposed to the other code, like that's part of the Ruby on Rails application that just sort of invokes Chiasm and passes the data into it from the Alpine system. So yeah, I had to deal with that. So I want to talk about the sort of future plans for the project, but are there any questions so far, anything you want to discuss? You can keep it sort of free form, I guess.
How do you add the tooltips to hover over and get information based on where the user's mouse is? Can you add that into something like that?
Yeah, it's funny you bring that up. So tooltips.
Really changing data.
Right. So by tooltips, I'm assuming you mean something like this, where if you hover over something, it shows you like the number for that particular thing. This is just a one-off D3 example that I did to figure out how to make tooltips. But yeah, I don't have any Chiasm examples that have tooltips yet. But these are the issues in Chiasm, and I made this issue recently of like, these are the things that I really want to support in the system. One of them is tooltips that follow the mouse. So I'm thinking that should be like a separate plugin that could then be just connected to any visualization. But for that, I need to sort of change the layout, how the layout plugin works, because the tooltip is going to appear on top. Or I could just have the tooltip be like not conforming to the layout plugin.
Yeah, that's why I was asking.
Yeah.
It seemed like it conformed.
Yeah, I mean, another issue in here is like I want to refactor the layout plugin such that instead of just vertical and horizontal partitioning, you could have like Z, like popping out, like overlay partitioning, and that would fit really well with tooltips.
Should it not be like listening to based on your mouse event changes, and then when you're and then using it as a link, and then some function?
Yeah, so like what I want to do really is add hovering functionality to all the plugins, so that like if you hover in a scatter plot, just move your mouse over a scatter plot, it should tell you which point that you're closest to. But to get a tooltip working, you need to actually get at the data element and then present the data record. So how do you do that? And like Mike Bostock, the creator of G3, has this sort of genius way of doing it with this Voronoi overlay, which looks like this. And the point of this is to, like, as you hover, get the point that's closest to your mouse. And there's this way of doing this in D3 with this Voronoi overlay. And so I want to sort of add this Voronoi overlay thing to all the visualizations and then have a property that's the same across all the visualizations, like hovered row or hovered data element, hovered value or something. And for that, you also need to specify which column of the data set are you interested in.
It would be nice to have a drop-down for that.
Yeah, it would. It would. Yeah, a drop-down would be nice for a lot of things in Chiasm, like the X column, the Y column, the color column. That's another sort of future direction I want to go, is like have automatically generated UIs for each of the components. Because like conceivably the plugins could describe what kind of user interface element would be appropriate for editing each of the fields, you know? And then in which case you could have an automatically generated UI pop up with like a drop-down menu for X, drop-down menu for Y, and like a slider for the minimum and maximum size, things like that.
Is there a plugin that's a good template for people who might want to send you pull requests? Is there a template that's entirely abstract?
Well, plugins. So that's sort of why I made the dummy viz plugin.
Right, okay.
This is like the basic one. And so, but it might be like too basic because there's not any visualization going on. But it shows you the basic structure. If you wanted to create your own Chiasm plugin, this is sort of where to start. It's basically a constructor function that takes as input a reference to the Chiasm instance. And the Chiasm instance has an API where you can actually change the configuration of any plugin. That's why the editor itself could be a plugin. And so it makes a model, an instance of this model.js model, and then sets, public properties is something I had to deal with because I want to eventually support undo and redo. And if you have a configuration that doesn't have any value for a certain property, then that property gets its default value, right? And then let's say you set a value for that property, but then you want to undo that action. Undoing that action would mean removing that property from the configuration. And so when you remove a property from the configuration, the system has to know what the default value was in order to restore that default value. And so that's why I had this idea of public properties. So every model, every component plugin, every plugin needs to declare a set of public properties. These are the properties that you're allowed to change through the configuration. And all these public properties need to have default values. So yeah, I have color, text, line width, and size as public properties here. And then here is constructing the DOM. It's like adding SVG, adding a rectangle, adding some text, and then adding these lines that make the X. And then it uses model.js, model.when, which is like quasi-functionally reactive programming. So like whenever the color changes and when the color is first defined, this function gets called, which sets the fill style of the background rectangle for this. So yeah, it's just in response to these properties changing, it's manipulating the DOM elements using D3. And then box is a special property that gets set by the layout plugin. So you need to respond to the box property by in this case, changing where those X lines go. And what else does it do? Yeah, when the box changes, set the size of the SVG element, width and height of the rectangle based on the new box. So yeah, this changes whenever the user resizes the whole page. So I didn't show you that actually, but yeah, in all these demos, like if you run them full screen, they respond to resize events correctly. And like a lot of D3 stuff just doesn't handle resize. And I've seen a lot of people run into that, you know, because the blocks.org examples are like a fixed size, and then you have to put that in your application and deal with like resizing, and it could be a headache. So yeah, the layout plugin abstracts that away. So that's awesome. That's really cool. Whoa. Hello. So yeah, resizes correctly. But notice that the editor doesn't resize. That's because it's defined in terms of pixels, 400px. But if I were to make it, yeah, you can have absolute and relative together in the same layout. Oh yeah. Isn't that cool? Oh yeah, yeah. It's pretty much a responsive design. It's not actually, because what responsive design would do is like as it gets smaller and smaller, it would be on top of C maybe. But this, it doesn't quite. It's not exact. So responsive CSS design, like they have these specific bins of sizes to detect, like, is it a mobile device, is it a tablet, or is it a full desktop? And
maybe 3 entirely different layouts.
Yeah, totally different layouts. But this doesn't do that. It's a fixed layout, but it just sort of scales. Yeah. So yeah, DummyViz is the basic plugin to look at. And then, oh yeah, right. Right, so I have some goals for like the future of this project. And I want to explain though that this maintaining the synchronization between the configuration and the runtime environment is based on this idea of just executing actions. And there are only 4 kinds of actions that can be executed. So like the whole system, all the running system that you saw is just a result of these 4 actions being executed. And so one of them is you can create a component based on an alias, which is the ID of it, and then a plugin, which is a string that the runtime environment interprets in a specific way and actually loads the plugin. You can set a property on a component. So you refer to the component by its alias and then set a certain property to a certain value. And then there's unset and destroy, which are inverses of set and create. So when you unset a property, that's really removing it completely from the configuration. So that value will have its own internal like default value. So that's why all public properties need to have a default value defined. So you can unset their fields. And then there's also destroy, which is the opposite of create. You know, it removes. So it manages the whole life cycle of these components. So if you call destroy on a bar chart, it will actually remove the bar chart, all the DOM elements from the DOM. And that's how that one example was able to actually scroll through different configurations where visualizations were coming and going. And I managed to get like all the memory leaks ironed out. So that was tricky. But the reason why it's designed like this are to support 2 main features. One of them is do and undo, like undo, you know, undo, redo, basically. But the more general version of that is a history graph. So these dots are states of the system, and when you interact with it, you change from one state to the next state. And then when you undo, you know, you go back to the previous state. And so because it's designed as actions, whenever you change something, it's just a bunch of actions. You can represent doing something as an array of actions. And then for every array of actions that actually gets done, you can come up with an inverse array of actions, which is the undo array of actions. This is not implemented yet, but it could be because of the design. What's that? Yeah, I mean, so the question is the granularity of states. Like, yeah, that's a problem that's going to come up because, like, I don't think you would want to create a new state on every single, like, mouse event. Maybe you would. Then you'd have a lot of states in your history. And so that every time you undo, you would be, like, moving your brush, like, a little bit, you know. So probably what you would want to do is, like, throttle the events. And so, like, take a snapshot every second or something. Right. Right. But if you think about it like this, like if you handle every event as a new state, because you have it as a graph data structure, you could conceivably have some algorithm that removes a state and then makes this connection be like the sort of sum of the two other edges and do the same thing with the inverse. So you could actually like create a massive state graph, but then like remove things later for efficiency based on a timestamp or something. I don't know. I haven't got to there. I haven't faced that yet. But that might be a solution that would come up. Yeah. And then the second major feature that I want to implement is real-time synchronization, like Google Docs style, you know, where somebody makes a bar chart, like 5 other people who are connected into that like room would see that update. And this is also enabled by this action setup. So if one client does something, that's an array of actions, right, that could be sent to a server. That server could broadcast it out to the other clients, and then they could like execute those same actions on their system. So these are different computers, you know, different web browsers connected to the same server. And it's totally feasible. I haven't implemented it yet, but I think it's like completely feasible. That would be amazing, right? You could have Google Docs for visualizations. Like, it'd be really cool. Right. So those are the 2 main features I want to implement in the future. And also, I want to build out the plugin architecture, like make it a real usable plugin architecture. Because, like, I feel like right now, if somebody comes to the project and looks through the source code, it's like it's not like refined, like it's still just getting started, you know, there's not like a clear path for making your own plugin, but I want there to be, and I want it to be easy for people to make their own plugin and also use plugins that other people besides me create. And so, yeah, to have a real plugin architecture, I think these are the things that I need to address. Like it needs to be easy to use a plugin, create a plugin, test a plugin, as in like, if you're making your own plugin, it should be easy to write unit tests for it that run. And I ran into this as a real headache, like trying to get the unit testing environment working with the browser and everything. And also, you should be able to bundle an application. Like if you have a Ruby on Rails application and you want to use the Rails asset pipeline, it should be straightforward to pull in the set of plugins that you want to use into your own bundle and then minify it or whatever for production and then put it into your larger system. Because like the application for Chiasm really is like you have a system, you want interactive visualizations in it, and you want to like take something and just embed it, right? And so that's sort of, yeah, the goal. So the tasks specifically are like creating a plugin. I want it to be as easy as like creating a GitHub repository and tagging a release. Because you need to, when you use a plugin, you should just be able to modify the Chiasm configuration. That's not in there right now. The bundling of plugins is currently separate from the configuration of the runtime environment. And that's something I want to address. I want to have like almost a meta level of the configuration that says like this, like the bar chart plugin actually refers to like the bar chart NPM module called like Chiasm-bar chart version 4.2, you know, so that the version should be fixed. Because otherwise, like if somebody else takes that configuration and tries to run it with like an updated version and the API changes, then the whole thing would break, you know. So these are some of the challenges I'm facing now of like how do you specify a complete system and have the bundling and installation of these modules taken care of for you. And yeah, to release an application, you should be able to run the Chiasm bundler, which doesn't exist yet, but it should. Yeah, I want to build this build tool that will introspect on this Chiasm meta configuration with all the plugin paths, and then that should automatically fetch all the plugins from NPM or Bower or wherever, or GitHub, and then create the bundle and give you a bundle so you can put it in your application. And I've evaluated a ton of different tools. Originally, I was using Bower and Require.js, which was really popular like 2 years ago, And so I was using those up until I finished my PhD, and I came to San Francisco, and I realized, like, oh no, like those tools are dead now, Actually, I switched away from Bower and Require.js when I had to create a bundle, and I'm like, oh, like Require.js says that it can make a bundle, but like I get all these errors and everything, and like I just was never able to get it to work. So I switched to NPM and Browserify, which are like the Node.js community tools. You can access. How many are familiar with Node.js? So yeah, like it's pretty amazing. There's this thing called Node.js, which is a JavaScript runtime environment that is inside of a process, and it can interface with like the POSIX API, so you can have like server-side programs written in JavaScript or command line tools written in JavaScript. And then NPM is the Node package manager. So it's a package manager for JavaScript packages, and it's like really super professional and clean and everything, and it works really well, So you can have like open up a terminal and say npm install Chiasm, right? And if I enter this, like it goes to the npm servers. They tell my code that like it's in this repository, and then it fetches from the repository or something. I don't know exactly how it works. So that fetches Chiasm, and it fetches all of its dependencies, which is D3 and some other things, Model.js. Model.js is there too.
Is this the recommended way to install Chiasm?
Yeah, it's the only way right now. Yeah, and it works fairly well, but the consequence of doing it this way is that you can't load modules dynamically. You have to bundle, So with Require.js is like you can't bundle. You can only load the plugins dynamically as you need them. And with Browserify, it's like you can't load the things dynamically. You can only bundle them all together and then load the one big file. And so if you look at the Chiasm source file at the root, it requires all the plugins and then sort of puts them on the chiasm.plugins property, which is like Chiasm's index of plugins that are already loaded. So that's sort of the current state of that. So that's the current strategy, NPM and Browserify. And then I'm using Mocha for unit tests. Oh, and actually I phased out Gulp. Maybe I should bring it back. I don't know. But the proposed strategy is to use this other set of tools called JSPM and System.js. And these kind of go together. System.js is kind of like Require.js. It's a module loader, but it can also load ES6 modules. So ES6 is ECMAScript 6. It's like the next version of JavaScript that's up and coming. And a lot of people are writing code in ES6. And it's amazing. It has a lot of new language features. And JSPM is a package manager that can actually load packages from NPM. And it can also load packages from arbitrary GitHub URLs. In arbitrary URLs, I think. If there's a JavaScript file floating around somewhere, I think you can load it with JSPM. And you can create bundles, with one big file with all the plugins. So I would like to build this Chiasm bundler thing that uses JSPM, and then the versions of everything is configurable. And so then you could have an environment where it dynamically loads the plugins, or it just loads a bundle with all the plugins. And so, yeah, that's sort of where the project is going. So that's it. Yeah. Thank you.